I have explained the pressures produced by ions and electrons. The density of the electron is increasing, then degeneracy pressures. We need to consider further increase in the densities. Degeneracy pressure of electron plunges to the relativistic degeneracy pressures. In these sessions, I'd like to explain the pressures generated by photons. So I'd like to explain how to produce pressure by photons. When a photon is absorbed or scattered by the gas molecules, photon has a momentum. P is h over lambda. Lambda is a wavelength of light. And the gas molecule absorbs the photons. Then energy state of the gas molecule is increasing. When higher energy state of the gas molecule is plunged to the lower energy state, gas particles emit the photons. So photon is emitted, but direction of the emitted photon is random. Sometimes in these figures, I show the photon is emitted upward directions. Then as a reaction, gas particle has a momentum in the opposite directions with respect to the emitted photons. But as I said, emitted photon is directed random direction. Sometimes to the left, to the right, and then to the other direction is possible. Momentums of the gas molecules has a random direction. So net gain of the momentums by the emissions of the photon is gonna be 0. But originally the photons is absorbed by the gas particles. So original momentum of the photon is absorbed by the gas particles. Net gain of the momentum of the gas particle is due to the momentums a photon originally has. So this increase in the momentums produce the pressures. I'd like to show you how to calculate the radiation pressures. So in the radiation pressures, distribution functions of the momentums of the gas molecule is a Maxwell distribution. In the case of the photons, in this lecture I don't explain it, but if you study the thermodynamics or statistical physics, you are going to study it. Distribution of photons is following the Planck functions. Because of these discoveries, Planck won the Nobel Prize in physics. Planck created a new branch of the physics, of the quantum physics. Then we use the same equations for the pressures. Pressure equation is here, but in this V is the velocity of the photon. We use a V is a c, because the speed of the photon is the speed of light. And the momentum is a h over lambdas. So lambda can be expressed c over nu. So you can substitute these lambdas here, then you will get P is expressed. This Np dP is actually equal to the N nu d nu. So instead of the Np dP, you can substitute these distribution functions, Planck functions. Then I'd like to show you how to calculate. So pressures is expressed actually 1 over 3, 0 to the infinities. So for the V is the speed of light. For the momentums, you can substitute h nu over c. And the distribution functions, 8 pi nu squares over c cube, 1 over exponential h nu over kt minus 1 d nu. So c is going to be cancelled out. Then you can introduce a new variable, the u, h nu over kt. Then this equation is expressed 1 over 3, 8 pi h over c cube times kt over h to the fourth, and 0 to the infinities, u cube over exponential u minus 1 du. So this part, constant value, is expressed 1 over 3 8 pi k to the fourth t to the fourth over c cube h cube. The question is to perform these integrals. Then I'd like to show you these integrals. 0 to the infinities, u cube over exponential u minus 1 du. Now we'd like to consider inside of these quantities. Then u cube over exponential u minus 1 is expressed exponential minus u cube over 1 minus exponential minus u. So if you consider this part, consider sum of the infinite series 1 plus alpha square plus alpha cube plus blah blah blah, infinite series. Then it becomes 1 over 1 minus alpha, when the alpha is smaller than 1. So we use these relations to express this red part. So it becomes exponential minus u cube. So infinite series you can use k equals 0 to the infinities, exponential minus ku. So it's gonna be u cube k equals 0 to the infinities, exponential minus k plus 1 u. So if you change the k equals 0 to the k equals 1, so it becomes u cube sigma k starting 1 to the infinities, so exponential minus ku. So we have an expression. So u cube over exponential u minus 1 could be expressed this equation. Then you can substitute back to the integrals. So I'd like to write down the equations. So u cube over exponential u minus 1 0 to the infinities du is expressed sigma k equal 1 to the infinities 0 to the infinities exponential minus ku u to the cube du. J change the variables y equal ku. So dy is exponential dy equal k du. So change the variable from the u to the y. So then this becomes sigma k starting 1 to the infinities 0 to the infinities exponential minus y. So u is y over k cube. Du is dy over k. So this means k is 1 to the infinities 1 over k to the fourth 0 to the infinities, exponential minus y cube dy. So if you remember the gamma functions and the Riemann zeta functions, so this part is exactly equal to gamma 4. This part is a Riemann zeta functions, Riemann zeta 4. So as I explained, Riemann zeta 4, this part equal pi to the 4th 90. This part is a factorial of 3, so this is 6. So answer, this integrals becomes pi to the 4th over 15. So we have these integrals. Then back to this equation. So this part is a pi to the 4th over 15. So it becomes these equations. So if you choose that this part is A, you can final answer of the pressures is expressed 1 over 3, 80 to the 4th. And the A is a radiation constant we called. So this is the pressures due to photons. Okay, this is the end of this session.